Yeah, hi all. So today we would like to see the coding problem of knapsack problem, and as usual, so we will go through theoretical analysis and time and space complexities, any improvements and implementation of that part. So what is this problem about? So if you have been given what is knapsack? Knapsack is just a bag. So and we have been given this array of items. Each one is an item. This one is item. This is item. So this the first element gives the value of the item, and the second element gives the weight of that item. So we have the four items provided as in the input array, and this is the maximum capacity of the bag. So 10 kgs of the bag. So it can take 10 kgs. So the question is, what is the maximum value from the items that we can take from these items, and we need to get the maximum value out of the items which we pick. So the answer for this is, so it will produce a value of 10, and the items are these: first index, this, and third index. 0 1 2 3. First and third indexes 1 1 and 3. So what does this mean? So it gives a value of 4, and this gives a value of 6, which is 10, and this gives a value of this weighs 3 kgs, and this weighs 7 kgs. So 3 plus 7 10 kgs. We are completely using the capacity of the bag. So the main thing is getting the maximum value out of this maximum value among the chosen items. Okay, so how to deal with this problem? So as usual, so this is a dynamic programming problem, and we need to take smaller chunks of the this capacity. Say if we have got just 0 kgs capacity of a bag, that means it cannot hold anything. This I am taking this as a base case. So similarly, 1 kg of capacity of a bag, and 2 kgs, 3 kgs, 4 kgs, 5 kgs, 6, 7, 8, 9, 10. Okay, and similarly I am on the right side, on the here I am taking the items. So I am taking an empty item. So as a base case, so I can use that as a base case. So it is an empty item, it doesn't produce any value. Okay, so in the next one I'm taking one item, in the next one I'm taking second item, third, fourth. Okay, so uh, this part I'm going to calculate the what is the maximum value that it can produce when there are no items and 0 capacity of your bag. And similarly, these are the items and the values. Sorry, these are the items and the capacity of the bag or knapsack. So okay, so if there are no items and we don't have any capacity of the holding, so the maximum value it can produce is 0. Similarly, when there are no items, although the capacity of a bag can be anything, so it cannot produce any value. So it will be still 0, the maximum value it can produce. Similarly, when we don't have any capacity of the bag, although we have any items to put, we can't put anything and we cannot get any value. So similarly, these also zeros, 0 value that we can get. Okay, so if this item is present, so when I say when I going to fill the maximum value that we can get at this point is, we need to calculate, we need to consider no items and also one item, and we have a bag of 1 kg capacity. So here, see, if you see, this is of value 1 unit and weight of 2 kgs. So can we put 2 kgs object or item in 1 kg bag? No, it's not possible. So the weight, the value it will produce is 0. So similarly, when we go here, we have 2 kgs item and we have 2 kgs capacity bag. So we can definitely get a put that item in the bag and get a value of 1. So okay, so we have 2 kgs and we can definitely keep in 3 kgs bag, and it will produce a value of 1. Similarly, we have this object, and similarly we can keep in uh, bigger bags, bigger capacity bags, so we can get the value of 1. Okay, what about here? So when we come here, so we have got these two items along with the empty items, so we need to consider this part too while calculating this, for calculation of the maximum value getting of the items. So we have 1 kg bag and we have 3 kgs item. So can we put? No, we can't put. So can we put 2 kgs bag in a 1 kg item? So what I mean is, if we can't calculate here, if we are not going to consider this, I'm just going to check in the top row. I am just considering the above item. So that's not possible too. So the the maximum value that we can produce is 0 here. What about here? So we have 3 kgs bag, and we have 3 kgs item, and we have 2 kgs bag, so we can't put. But if you see, we can't put this item, but we can check this item. So can we keep 1 comma 2 kgs item in 2 kgs bag? Definitely yes, and we can get a value of 1. So what does this mean here is, so if we can't consider this item, you go to the top row, I minus 1th row, and that is the exact value we get here in the ith row. That is kind of formulation what is happening here. So we go forward, and we have 3 kgs item and we have 3 kgs bag. That is one possibility we can definitely keep, and we get a value of 4. So we consider this item too. We have 2 kgs item and 3 kgs bag we can keep, but we are just getting 1 unit of value. So when compared with 1 and 4, so 4 is maximum, so we will take that maximum item and keep this item in this bag. So going forward, so 4 comma 3, this 3 kgs item we keep in the 4 kgs bag. That's possible, and we are getting a maximum value of 4 here. And similarly, so yeah, if you see closely here in the next item, we have 5 kgs bag and we have 3 kgs item. So we will keep the 3 kgs item in the 5 kgs bag. So that is one point, and we have still left 2 kgs 2 kg space in this 5 kgs bag. So what does this mean? We can keep this item 2 inside this. So how can we formulate that here is, so we get a value of 4 units by keeping this item in the 5 kgs bag. That means we keep the item in the bag and we check, can we keep this item in the remaining 2 kgs 2 kgs bag. So this is what, so this is the exact number which will give this. So 1 kg 1 unit value. So we add this 1 plus 4, which gives 5. So what happened now? The formulation, if you consider this, and if you are going to consider the above element too, we just go to the top row and go back this many weight times. So what does this mean? 5 minus 3 2. We just have gone here and added this value and the value which we get by adding this, so 5. So yeah, that's the basic formula, and we will calculate this row too. If the capacity is 6 and we have got the 3 kgs, so what happens? So 3, we will put the 3 kgs item in the 6 kgs bag, and we will get a 4 kgs value, 4 value, and we will also keep we will also get we will also keep this 1 comma 2 item, which is still possible. Or according to the formulation, what we will do is, we got where we are considering this item, which gives a value of 4, and just go to the top row in the same and subtract this weight, 6 minus 3, which gives 3. So what is present in this? So it is producing this maximum value, so 1, which is 5. So 5 is what gets here. So similarly we have 7 kgs bag and 3 kgs item. So we will get by taking 4, by taking this item, and we will just go to the top and subtract 4 minus 3, which gives 4. What is present in the 4? 1 is present. So 5 is the maximum value we can get. And similarly here, so we have the similarly, yes, still 1 is present above, we will get 5, 5, 5, 5. Okay. Okay, so okay, if you consider the formula, what is happening? So there are two possible cases here. Either you go with putting the item in the bag or not putting the item in the bag. If you put the item in the bag, which means the item weight is less than the capacity of the bag. That is one condition. Okay. So if the item weight, if the current weight, I can keep that as W. I will take, I will, this is value and this is weight. If the weight is less than the capacity at that moment, which you are calculating, so what we can do, the value, I am calling this array which we are building as values. So the values at I comma, I will call this I throw, and I as capacity C. So I C is equal to, you can call as ij, it doesn't matter. I am calling it as ith row and cth column. Okay, so what will happen is, if we consider the item, so we will keep, we will just keep, so the max of, so just above the this element, values of I throw I minus 1 and cth column, plus what we have added here, we have added, so this element, we have added the value which we are getting to this, to I would write max of values of, just I will call this as v value. So we are adding value plus, so values of I minus 1 throw, and we are subtracting c minus the weight, right? So this is what happening. So this is one possibility. Or if we are not going to consider this value, this item, we are just gonna put the above item, and the value which was produced by taking that item and keep that value here. So just I minus 1. So either this one or values of I minus 1, I minus 1 and the same column. So this is the maximum weight which will produce this whole values 2 by 2 matrix. Okay, we can calculate. Oh, this is 6. Okay, okay, we can easily calculate this. It is obvious that we can't keep this mm, 6 item in the below. So what will happen? We just talked. If we can't take this item, what we'll do? We will just place what is present above and keep this below, because this is not considered, and we will consider this. We got some value out of by keeping this item in the bag. So we that is the value which we will get by not taking this. So we will just copy up to here. When we are in a position where we can keep this 6 kgs item in the 6 kgs bag, then we will recalculate the value. So what happens? We can keep this item in the 6 kgs bag. So by keeping this, we will get a value of 5, and we're completely using that. So it would be 5. Okay. So what about this? We have got 6 kgs item and 7 kgs bag. So we can keep we can keep the 6 kgs item in the 7 kgs bag and get a value of 5. Along with that, we can subtract. We can go back 6 times. So 6 times from here means 7 minus 6. Go to 1th index, which gives 0 value. So put as 5. So what about the next one? So 5 plus, so 5 plus 8 minus 6. 8 minus 6 is 2. 2, what is present in the 2? So this will give you a value of 6. Okay. So what about the next ones? So this 5 is constant. We are taking this item because we can keep in the bags. 5 plus, and we are subtracting 9 minus 6, 3, which is 4. So 5 minus 4 is 9, and similarly 5 plus 10 minus 6 is 4th index, which has got a value of 4. So this is also 9. Okay. So I am just applying this formula. So I am just adding V plus I minus 1 C minus W. C is the capacity, and 10 minus W. W is the weight which is present over here, and calculating the last row. So similarly here, until we reach the 7 kgs capacity bag, we can't do anything. Just copy the above one in the bottom. Okay, so we got here. So 7 kgs item or 7 kgs bag. So we can get a 6 kgs value, 6 value, and 7 minus 7, which gives 0. 0 is 0 value. So 6 here, and 6 plus, so 7, 8 minus 7, which is 1, 1th index, which is also giving a value of 0, so 6. So 6 plus 9 minus 7, which is 2, which is giving a value of 1, so 7. This gives you a value of, so I assume I did correctly, but double checking. So 7, 9 minus 7, which is giving a value of 2, which is gonna give 7. Okay, I will see this. And what about the final one? So we have the 10. Okay, we have, by taking this, we will get a value of 6, and So as per our formula, we are taking this and just go to the top row and 10 C minus W. Capacity 10 minus W is 7. 10 minus 7, 3. Go to the 3 and it will give you a value of 10. So this is 10. Okay, so yeah, this is what. So finally we will return. Yeah, this is the answer as we talked previously. So 10 is the maximum value we can obtain by getting the this element and this element. You can this element and this element, but we got the maximum value we can get between these. But what is the possible way of getting the order or items which need to be picked? So that can be done using a backtracking process from here. So from here we will choose, we go back to the zero position, to the zero value position. uh, okay, so the same formula which we calculated here in a different way, we apply here. We will see from here. Okay, this position produces a value of 10, the above produces a value of 9. Is both equal? No, it's not both equal. So what happened? So we, if the both are equal, which means that we haven't considered this value. If those are not equal, what does this mean? It means we have considered this value and we have proceeded. So that means we have taken this item. So we need to append somewhere in the our code this item as one of the item which we picked in the process, and we proceed back. So we have came here and we will check that we have reached here, and we have kept the weight of 7 kgs in the 10 kgs capacity bag. And what is remaining now? So 10 minus 7, we got 3 kgs. So 10 minus 7, go to the third index and see here. And what is present here? 4 and 4. So check what is present uh, exactly above it. So 4 and 4, which means equal. What does it mean? So we haven't considered this item anymore for our calculation. So go to the top and see if uh, if we have calculated uh, the above. Just see the what is present above, just above. So 4 and 1, which means there is a difference in the both items, and that means we have taken this item in calculation of the maximum value. So so that means, so v is the maximum value that produced here. And okay, from here, so we will just subtract the, we are here, so subtract the weight. So capacity minus weight, 3 minus 3, go to 0. So we have reached 0 items. So when reached the 0 items, what does that mean? We have completely filled the capacity and we need not to go proceeding further in the backtracking process. So this is the item we have taken one more, 4 comma 3. So these are the items, and we will store the indexes as 4 comma 3. This is 0, this is 0, 1, 2, 3. So 1 and 3 are the items we have picked here. So that's the process here. So yeah, so we will talk about the time and space complexities. What is happening? Time and space complexities. So what is happening? We are iterating through every row which is of length equal to the length of the given items, and we are iterating equal to length of 0, 1 plus 1 plus capacity times. So 1 plus capacity times is obviously capacity we can approximate, and so capacity times into the length of the items gives the time complexity. So if you take capacity as C and number of the items as n, so it will be C into n, this time complexity. And in the process, we are building a new array which is of time complexity of C into n. So these are the two time complexities, and we need to implement this. Okay, so we will start. So the coding part, we keep this formula as it. So definition of knapsack, which will take two items. One is items, items list, and capacity. Okay, so what is the thing? So previously we have constructed that two-dimensional array, mm, two-day array, and starting we need to initialize that array. So I will keep the values. So values is equal to initialize with zeros. Initialize with zeros. So 0 for what is the number of the columns it need to present. So 0 for x in capacity. So x in capacity plus 1. Uh, I mean, for x in range of len of capacity plus 1. So we have talked previously that we have got 0, 0, 1, 2, 3, so on up to 10. So 1 to 10 is 10 numbers and 0 is one more number we have taken for base case. So the total will be 11, which we get by 0 to length of the capacity 0 to 10. So plus 1 I have added here. And this need to be, this row has to be present how many number of the times. So the items plus one number of the times. So for maybe for I in range, length of items, this is also plus 1. Okay, okay, so we have initialized the values here. So we need to proceed for calculation of the here we need to iterate for I in range. We need to iterate in the row. For I in range, length of, oh, by the way, we have already calculated the zeros. We have already put the zeros, which is obviously the zeros for the first row. So we can just proceed with 1, starting with 1, and to length of items. We need to go to still plus 1 times. Okay, and okay, so we have come we are trying to iterate, and we need to for I in range 1 plus 1 to length of items plus 1. Okay, so we need to see what is the current capacity. So what is the current capacity? So that would be capacity for, okay, see, this is the pseudocode. So we need to calculate the weight and capacity, and I minus 1, j minus 1, I is here, and so current capacity is equal to current capacity or what. So I'm thinking, so we started from first row. We have already kept zeros here. From the first row, we need to see the values and weight. So current weight, so what would be the current weight? Current weight is equal to, we have kept here 1 comma 2, 4 comma 3, and 5 comma 6, and similarly 0, 1, 2, 3, so on up to 10. So how will we get the current weight for this after starting with? So current weight is items. We have the items of I minus 1. If you see why this is happening, so we are starting with 1 here as I. So 1 minus 1 is 0. So items of 0 is here, and we want the current weight. As we told, the first one is value and the second one is W. So we are going to get the first index, so this one. So and current current value, this in the similar way, I minus 1 zeroth. So we got the current weight and current value for this. Okay, so we need to iterate in the inner loop for, we iterated horizontally like in the rows, and we need to calculate the capacity C. For C in range, we need to iterate. We can iterate actually from zero to how much length? Zero to length of the capacity. If the length of the capacity is 10, so it will iterate from 0 to capacity. So we need to add plus 1 here to go to 10. Otherwise it would stop at 9. Okay, so we have iterated the vertical portion of the columns. Okay, so we need to calculate, we need to check, okay, if mm, if the given current weight, just this, if the given current weight, is greater than the capacity, given current weight, if it is greater than the capacity, we can keep the item in the bag. So we can calculate the values here. So we have values of I comma C is equal to what we can keep here. If this is less than this, what we have talked, we can keep that item, and if we have taken that item, the current weight is greater than the capacity, Oh, I mean, oh, sorry. So if the current weight is greater than the capacity, what does this mean? So if the capacity is more, if the is capacity is less, we can't even put that weight in that bag. So what we will just do as we talk, we will just put whatever present in the top row in the same column. That will actually make this value. Or else, if what happens, if we can, if it is less, if the current weight of the item is less than the capacity, so we will keep values of I comma c. As we talk, we will keep this item. So max of values of I minus 1 c or v plus. What is v here? V is current value, right? So current value plus, so current value plus values of I minus 1 comma c minus c is capacity. So we are getting c minus current weight. Okay, so this makes the this iterates for all the mm, times, and we will get the we will build the whole two-dimensional array with this. So and finally, what we need to return, we need, excuse me, we need to return we need to return so this value. So 10, what is 10 here? It will be the last minus 1 value. So values of minus 1 would give last column. This is this value, and this going to be sending a list, and this iteration, this sequence, we need to calculate in a different function, in a helper function, you can think. And that would be a, I will call a get sequence get sequence function, and we will pass two values, the values array which we built here, and the we are passing the array and the items. Okay, so this completes the actual this part, this calculation of this part, and for sequence we need to do like this. So where we created a get sequence call here, and we need to implement that. If you see, this is iterating n into c times, so this is the time complexity for this. Okay, so we need to write a new function, definition of get sequence, which takes the created 2 by 2 matrix, which is of value, which was named as values, and the other is items. These items we are passing. So what need to be done here? We need to backtrack from here to back. Okay, so how are we doing it? So we need to initialize the indexes, like say I is equal to, so I am taking I and C here too. So I and C here is I is the last row. What is the last row? How can we write this? So it is length of items, length of the items. So if the four values are there, 0 to 4, 1, 2, 3, 4, 5, 6, 7. So this is 0, 1, 2, 3, 4. So how can we write this? Length of the array will give 4. So is it correct? Length of the values. So this is the value. So length of the values. Okay, we are already keeping this as values, right? So we can just write length of the values, length of the values, and minus 1, because if there are 5 rows in this, so the index would be the last row index would be minus 1, just 4. And what are the number of the columns? We have these values, and so we can write like this. So how many number of the columns is length of the values, length of values, the first row, those number of columns, just minus 1, which would give the number of the last index of the column. Okay, so after this we need to backtrack. So I will try to write like this. How can I write this? So we need to backtrack, and we need to update. We need to basically check that the last row value, is it equal to the previous row exactly top element. If that is equal, that means that row is not considered. Okay, so I will proceed like this. So while I need to make this as I greater than 0. So I need to iterate until maybe 0, and I need to I need to check what I told just now. If the values of I, the last row and last column, is it equal to the previous row and values of I minus 1, the same column. Okay, so what does this mean? If it is equal, we will just just go to the previous row. What does this mean? We will just reduce minus 1 row by minus 1. Okay, if that is not the case, we will if it is equal, we need to grab that index and put it in some sequence. Say I will create a sequence array, which I would return to the previous function which we called there. And else, if it is not equal, so what does this mean? We need to append sequence dot append. What is the value you will append? So this is of ith row, this is of I, but from a point of this given input array, this is if this is 4, if this is 0 1 2 3 4, um, I what is this? I is equal to length of the values 5 minus 1, which is 4. But here if you see 0 1 2 3, still it is not 4, it is 3. So you need to reduce minus 1 here. because we have added 0 extra here, so we need to reduce that I minus 1. And similarly, we need to go to c minus is equal to, so if you have taken this value and we need to subtract that from the capacity, so what we can do, we are subtracting c is equal to capacity minus what is present over here in this index. Um, the value, we can call this as uh, I items of I minus 1. And so this is value and this is weight, we need to reduce that weight, so this is 1. Okay, so you understood, right? So items of I minus 1. I just told items of I minus 1. Okay, so we need to reduce this value from here. And similarly, what we did, we need to go to the top rows. So just reduce this by 1. Okay, and if we reach the c is equal to 0 anywhere, we need not to proceed. If c is equal to 0, just break it. Just break it and return the sequence. Return the sequence, but to be conscious, for if we get here, we will get in this sequence 3 comma 3 comma 1, which is not our case, so we need to reverse that. Because we are backtracking, we need to reverse the list. Return list of reversed will give you a iterator, so we need to make this that as a list, so list of reversed of sequence. So this completes the problem and it will return the sequence. So I think that's it.